So we've done a video of a drop. You've gotten a graph like this. Now some of yours start off up here and come down. That's fine. You're just going to have negative acceleration, which means downward. For mine it was sideways, so it's treating it as a positive acceleration, which is totally fine too. So we know it's downwards. So how do we linearize this? What we want to do is you have d and t, yes? If this is quadratic, then what we're going to see is, in other words, if it's accelerating, then d equals vit plus half at squared, yes? What's our initial velocity with a drop?
0.
0. Boop. So really, d equals half at squared. Acceleration of gravity is constant, yes? So this part is just a constant number, or what could be a slope, yes? So what we want to do is we want to graph d, but not versus t. We want to graph d versus t squared. And if this is a quadratic relationship, then we'll see a straight line. Now, you could go through all of these times and just square them out. By the way, mine's not going to work very well because it's not starting at 0. So I'm going to go back into my video and I'm going to make it do that. If you double click on your video, oh no, now I'm putting in points. If you put in a bad point, push the select tool and click on your point and delete it. Double click on the edge and that'll open up movie options, and down at the bottom we want our first VA point to be 0. We say okay, and you'll notice that my times just changed so it starts at 0, and that'll make my linearization work better. Okay. Sterling?
How'd you do the 0 video thing?
Go to the movie, and if you kind of go in the gray margin edge there, a little hand will come up, and if you double click that, it'll open the movie options. And then you click in, I'll show you again. And then if you go to the bottom here, there's this first VA point defines movie time 0. So you click on that and then it'll start at 0. If you haven't done that, do that now. Okay. Now, we want to square all these times, right? You could get on your calculator and just square it and enter in a whole bunch of numbers. Some of you are going to go on in physics and engineering and research and other things, and there's all kinds of relationships like this. It doesn't have to be a tennis ball dropping. It can be a financial relationship. If you're working on Wall Street, physicists get paid a lot of money to look at relationships like that. We're going to get the software to square these times. You may have thousands of data points, or even hundreds of thousands of data points, and you don't want to do that on your own. We want to get a computer to do that for us. So this is how you do it. You go to data, and if you scroll down, it will say new calculated column. Click on new calculated column. We want to make a column for time squared. So you type in time squared, and I'm going to make my short name T2 so I know that it's time squared. And I have to make an expression. So down at the bottom here, there's this kind of open box, and if you click in there, we can write an expression for what to do with any of our variables. We want to square our time. So if you click on variables, it will show you all the possible variables in your graph. We're going to click time because we want to square all of our time values. So we click on time. And it's probably hard to see in the video, but it says time here in quotations. And then we're going to do the little hat and the 2 to make it squared. So you go shift, on my computer it's shift 6, and you see this teeny little hat, and you put a 2. So let me write this in big letters. It's going to look like this, time and a big hat and a 2. And that means the computer's going to square all of the time values in our data. When you click OK, say done, you should now have a separate column in your data. In mine I have T2. And if you go back and look, compare that to your original time, you should see that all your time values have been squared over here. That's what we want to graph against. So now, instead of having my x displacement over time, I'm going to open up my graph here. And down on my x-axis, I'm going to click where the time label is, because I want to graph now my displacement over time squared. So I click on this label, and I move up to my time squared, the column I just created. And I click on that. And for me, it worked out pretty well. There's a little curve at the beginning, but it's pretty straight, it looks like. And now what we want to do is calculate that slope. We're expecting this to be a straight line. So if you go up here, you can click this little straight linear fit button. Yes, Penta?
How did you do this graph? Can you repeat it again?
Yes. Let me click this and see for now. So it's close. Mine didn't work out like super well, but it's okay. Yes, let me go over how to do it again. Yeah. Hold on one second. So you start off with your curved line. You go up to data, new calculated column. Name your column, give it a little short name. Okay, and then in here, click in that box. Variables, time, and then that little hat thing and the 2. Click done. And then when you do that, you should see in your data a new column with a different name. Do you see that? Okay, and so now you click on this label down here at the bottom and find that label, this one, the new label that you created. If you didn't change the name, it'll say calculated column. Did it work? You have a straight line? Awesome. For units? It'll be meters per second squared. But you don't have to fill that in. So when you get your time squared, your linear fit 1, now you're going to cut and paste that in. And if you get all those things, you can submit that document. I'll make an assignment right now, and then you're done. Need help? Let me stop this video here.